Hello guys, today we're going to learn about rational functions and asymptotes, and this is the first one, so we're going to learn about the horizontal asymptotes and the 3 rules it has. Alright guys, we're going to start with rule number 1, and that's if the numerator's degree is less than the denominator's degree. So this would be like if the exponent on the top is smaller than the exponent on the bottom. So the example we're going to use x plus 1 over x squared minus 1. What we're really paying attention to is just the exponents. In this case, we have x to the invisible 1 and x to the second power. So our horizontal asymptote is going to equal y equals 0. And the reason why y equals 0 is because the one on the top is less than the one on the bottom. For rule number 2, what we have is that if the numerator degree equals the denominator degree. So this would be kind of like x squared minus 1 over 2x squared plus 1. What we're really looking at is that the x squared and the top and in the bottom are the same. So what we're going to pretend here is we're going to pretend that there's an invisible 1 in the front of the x squared minus 1. And what we're really looking at is the 1 and the 2 on the front, on the top, and the bottom. So this is going to have a horizontal asymptote equal y equals 1/2. Okay guys, well for rule number 3, it's if the numerator degree is greater than the denominator degree. So this would be kind of like x squared plus 1 over x minus 4. And what we pay attention to is the degree, so we're going to pretend that there's an invisible 1 on the bottom degree. And what we really look at is that, so our horizontal asymptote is going to be y equals none. And this is because there is no horizontal asymptote, but you cannot put y equals 0. If you put y equals 0, it's wrong because remember that's for rule number 1. And 0 has a value, and for this case we don't have a value.
Okay, now we're going to teach you guys how to find the vertical asymptote of a rational function. And in order to find the vertical asymptote, you use the denominator, and you solve for x in the denominator, and the result you get will be your vertical asymptotes. Here's an example. It's x plus 4 over x squared plus x minus 12. If you're able to simplify, do it. You must simplify. So once you simplify, you get x plus 4 over x minus 3, x plus 4. So remember, we only use the denominator, so you set x plus 3 equal to 0 and solve for x. And you do the same thing with x plus 4. You'll add 3 to both sides and subtract 4 from both sides, and you'll get x equals positive 3 and x equals negative 4. And those will be your vertical asymptotes.
So now we're going to talk about the x-intercepts. The x-intercepts are all about the numerators. So in our first example, say we have x plus 1 over x squared plus 2. We're only going to look at the top, which is x plus 1. So here we want to set x plus 1 to 0 so we can figure out what x is. So first we would subtract the 1 from both sides, and then we would get x equals negative 1. So now let's do another example. So say we have x squared minus 25 over x minus 3. Once again, we're only looking at the numerator, which is the top one. So here we would set x squared minus 25 to 0. Now we would add 25 to both sides, and then we would end up with x squared equals 25. So to get the answer to this, we would have to square root both sides, and that would equal x equals plus or minus 5, because for a square root, a negative and a negative equal a positive, and a positive and a positive equal a positive. But another way to do this is we factor it, so you would get x minus 5 and x plus 5. And the same thing with this, you would set both the equations to 0, so x minus 5 equals 0 and x plus 5 equals 0. And then add 5 to both sides, it's x equals 5, and then you subtract 5 from both sides, it's x equals negative 5, which is the same answer that we got up here. So now we're going to talk about the domain. So say we use the same example from last time, which is x squared minus 25 over x minus 3. The domain, now we're looking at the denominator of the equation. So here we have x minus 3. The denominator cannot equal 0. So here we would say x cannot equal 3 because 3 minus 3 equals 0, and that's a no-no. We do not want that. So now we are going to say that here we use negative infinity up to 3, but we put a parentheses because we don't want to include 3, because like we said, x cannot equal 3. So you unify that with 3 to infinity because x can equal all real numbers, but remember, x cannot equal 3.
We're going to find the whole or wholes of the rational function in this part of the video. So we'll be using x squared plus 6x plus 9 over x squared plus 4x plus 3. You have to simplify or factor the numerator and denominator and look for the common factors. And once you do that, you'll get x plus 3 and x plus 3 over x plus 1 and x plus 3. Notice that there's common factors on the top and bottom, and in this case it's x plus 3. So what we do is, if you look at the factor, you have to let it equal to 0. And in this case, once you solve, you get x equals negative 3. And note that at this value, a whole occurs. Okay, once you find this, now you need to find the corresponding y-coordinate of the whole in the graph. In order to do this, you have to look at the function and you'll see that you can cancel out the common factors. In this case, the whole, and you'll be left with x plus 3 over x plus 1, and you just substitute in the x equals negative 3. And in this case, you will, that will tell you the y-coordinate. In this case, it's 0. So then a whole will occur at negative 3, which you found previously, and then the 0. Okay, so now we're going to apply all that we've learned into one single problem, and we'll just use the problem we used for the previous example. And since we already solved for the whole, we know that the whole is negative 3, 0. And now we have to find the horizontal asymptote. If you guys need to refresh your mind, you can go back to the beginning of the video. And we can see that the degrees are 2 and they're equal. And one of the rules states that if the degrees are equal, you just use the value in front of the degree. In this case, it's 1. So it'll be 1 over 1, which is 1. So the horizontal asymptote would be y equals 1. Okay, now for the vertical asymptote. And remember, for the vertical asymptote, you use the denominator. But in this case, we have a whole here, so you only use this part. You don't use this part. You don't use the x plus 3, which is already under the whole. You only use what's outside of it. So just make it equal to 0 and solve for x, which you'll get very simple, negative 1. So your vertical asymptote is negative 1. And the same applies for the x-intercept. We use the numerator. You don't use the factored form that's in the square of the whole, so you don't use any of this. So only use this for the x-intercept, and like I said before, make it equal to 0 and x equals negative 3, and that would be your x-intercept. Now for the domain, you include both. It doesn't matter if it's already in the whole or outside of the whole, you include both. And like I said before, solve for x, and you will get your domain. And it's very simple math, guys. So it's x equals negative 1 and x equals negative 3. And now you have to write it, include the infinities. So it would be negative infinity up to negative 3, unified to negative 3 and negative 1, unified to negative 1, and positive infinity. And remember, you don't use brackets because we don't touch those numbers. And that's how you apply all the terms into one problem.